and parting line will be this. Okay, so whatever coming in main tooling direction, that you can consider in main tooling, and other things that you can consider in lifter. So this will be your lifter. Okay, and then what was the next point, other point? Okay, we will discuss the lifter slider also. Yeah, okay. So draft angle we already discussed. What are draft angles? If you want some definition, okay, this is the meaning of draft angle. You can see in both the pictures. Okay, this is without draft and this is with draft. So this is the importance of draft. Okay, now undercuts. Now if you see here in this video, this yellow color is your part. Okay, now if you see, this is your cavity. Okay, and cavity, okay, this is your cavity side and this is your core side. Okay, because this is the B side and this is A side. Okay, A side will always be in cavity, and this is the pin, and this is actually slider. Okay, because we have two hole. If I saw you there, okay, this will be your part. Okay, there will be two hole. So for clearing that two hole, we are using this slider. So commonly question, interviewer will ask, what he will ask, what is the basic difference between lifter and slider? Okay, so slider we use for external undercut, because see, that is inside. Okay, and for inside, suppose we have a doghouse here. Okay, so for that we need a lifter like this. For internal undercut we need slider, and for external undercut we need lifter. So this is the basic difference. Okay, so you can see this is another mechanism for the slider. Okay, cam mechanism. Then yeah, this is the lifter. Okay, you can see here exactly how lifter work. This is our plastic, okay, plastic part, and see, this is our main tooling direction. So in main tooling direction, this area would not be clear, right? This area would not be clear. So for that, this blue color, that is our lifter, and this mechanism is like this. Okay, and this is our core, and you can see there will be no gap. Okay, everything will be packed so that your material will flow in cavity properly. Okay, but still there will be one line mark. Okay, so if you focus on this video, you can see how it work. Okay, so this is how first lifter is going. Okay, first core, this is pushing this side. Okay, core is pushing this side, then our lifter is moving from here. There will be a mechanism. Okay, see, this is the lifter mechanism, and same lifter it will work if we would have, if here, if undercut will be here. Okay, like this, if this will be undercut doghouse. So this is how it will work. Now next, you can see here also, if you have a rib. Okay, so this is your undercut and some rib structure you are applying here. Okay, so you need to consider the lifter movement also, at what distance your lifter will come, and what how we can uh, what will be the distance for this rib, so that our lifter movement will be easy. So this will be depend on your lifter size will be around 20 to 25 mm. Okay, just generally take it. Okay, so if I show you lifter construction, a general lifter. Okay, this, and one pin will be there. You can consider as this is my pin. Okay, this is the raw diameter of the pin. Okay, sorry, there will be a raw diameter of the pin. Let me draw again. This is very huge. Yeah, this, then this will be your, yeah, pin. And for pin we have to, this distance should be 5 mm, this side 5 mm, 5 mm, and 5 mm. Okay, so dia for this I'm considering here 10 mm. So generally we minimum will be 8, 10, 12 or 14. Okay, so 10 is enough. So this is 5, 5. Okay, so this is coming 20, and this will be your undercut. Okay, this is going this much inside. So this is 10, and again what it is, how much, this is 20, 10, total become 30. Okay, so how much it will come back, 10, because of this, right, this 10, and by keeping 2 mm 5 mm clearance. Okay, so that is that will become around 45 mm. So till 45 mm there should not be any other features. Okay, so this is the general lifter construction we consider while designing something. Okay, you can see here again. Okay, so here what is the difference between this and this? See, lifter is moving this side. Okay, because you can see here this is, and in other this is like this part is like this. So what will be the lifter moment in that part, you can see here. Now lifter is tilted a little bit. This is the tooling direction, and this is also tilted here also. Okay, and this is your undercut case in case of doghouse. See, okay, so here lifter is not moving backside. Okay, we are doing here some manual operation. Okay, let's see. See, if you see here, there is no movement, no mechanism is there. So that's why manually we are pulling it at this side from the lifter. There's also written, operator or boss robot must be able to release the part by shifting it one direction. Okay, so these are the some CAD question generally maybe asked by the interviewer. Okay, so generally we will ask this kind of question, and the next is the coring. Okay, so what is coring? Do we have coring here? Now see, when you will provide, this is your suppose part, and this is the root thickness coming over here on the base part. What is root thickness? If I will take a section, okay, this is your base part. Okay, so yeah, this is your base part, thickness maybe 2.5 mm. Okay, 2.5 whatever the thickness. Okay, and this is your feature coming over this side. Okay, so this thickness what is given at the root, that is our root thickness. Okay, so in case of plastic is around is 40% only, 40% of part thickness. Okay, so if part thickness is 2.5, then this should be 1 mm because 40%. Okay,